There is no dark side. The phrase is very common, and it is wrong. There is a far side of the moon. There is no permanently dark side. Every part of the moon gets sunlight. The moon turns on its axis, slowly, and as it turns, the line between day and night sweeps all the way around it, just as it does here. A lunar day lasts about 29.5 of our days, measured from one sunrise to the next. So a spot on the surface gets roughly 14 days of sunlight, then roughly 14 days of night. The side we never see gets exactly as much sun as the side we do. When we are looking at a full moon, the far side is in complete darkness. When there is a new moon and we can see nothing at all, the far side is in full daylight. The confusion comes from the word dark being used to mean unknown, which it was entirely until 1959, when a Soviet probe called Luna 3 went around the back and sent home 29 photographs. They were poor photographs by any standard. They were also the first time anyone had seen almost half of a world that had been in the sky the whole time. The face that never turns away. The moon keeps one face towards us. This is not a coincidence, and it is not unusual. It is called tidal locking, and most large moons in the solar system do the same thing around their planets. It happens because the Earth pulls slightly harder on the near side of the moon than on the far side. Over a very long time, that difference acted as a brake on the moon's spin, until the spin settled at exactly the rate that keeps one hemisphere pointed inward. The moon does rotate. It rotates once per orbit, which is why the same face stays towards us, but we do not see exactly half of it. The moon's orbit is slightly oval, so it speeds up and slows down as it goes round, while its rotation stays even. It also tilts a little. The result is a slow rocking, back and forth and up and down, called libration. Over the course of a month, that rocking lets us peek a little way around each edge. Add it all up, and about 59% of the surface is visible from Earth at one time or another. The remaining 41% had never been seen by anyone until a camera was sent around the back. The other side is not the same. When the first photographs of the far side came back, the surprise was not the detail. It was that the far side looks like a different place. The near side is about a third, covered by those dark lava plains. The far side has almost none. It is crowded, pale, and cratered almost everywhere. The reason appears to be thickness. Measurements of the moon's gravity field, made by two spacecraft flying in formation and watching the distance between themselves change, show that the crust on the far side is substantially thicker than the crust on the near side. On the near side, molten rock could reach the surface and flood the basins. On the far side, it mostly could not. Why the crust should be lopsided in the first place is still argued about. One explanation is that the young Earth, still glowing with heat, warmed the near side and kept it molten for longer. Another involves a second, smaller moon that collided gently and spread itself over the far side. Neither is settled. So this is one of those places where the honest answer is that we can measure the difference very well, and we still do not agree on where it came from.